I'm Peter Haddock and we're here in the sun with Shane Gwilt from Leica Geosystems. Shane, what have we got here? It needs a little bit of a push, doesn't it, this one?
Yeah, so this is a mass array ground penetrating radar systems. This has 30 channels at a 600 megahertz frequency in a dual polarization. So what that means is we've got antennas in there in HH horizontal and VV vertical polarizations. So as we're pushing it along, what we're doing effectively is picking up a grid of GPR data. Right. So we're picking up a grid north, south, east, west. We're covering the ground looking for buried pipes, cables or services.
Now this particular sort of technology has now been on the Explore plant hire and transport fleet. Now that we see one of their JCBs behind us, which got Leica Geosystems 3D machine control and X-Watch collision avoidance. This is why this is important, isn't it? If we're to get the collision avoidance right in there.
Absolutely. So collecting that subsurface information, where the pipes and cables are at the outset of a project, is absolutely key to the safety aspect going forward. So if we know where those pipes and cables are at the outset of a project, we can map them, we can design with safety in mind. So if there's a pipe crossing here, the designers may be able to change their design slightly so the piles don't actually go straight through it. You know? So once we then get to site, we know where the subsurface information is. We can upload that to MC1. We can then ensure that the machines have avoidance systems in place to stop them digging at those sort of points.
So as we push further forward, we've got all of this information. Now, technically, what I want to know is what happens. So if we stop here, we come to the end of our survey. What actually happens now?
Okay, so at the moment what we're doing, as we're pushing it along, we're sending a radar wave into the ground and getting reflections back. And we're getting reflections back from changes in subsurface materials. So a pipe, a cable will reflect differently from the surrounding area. We're using a positioning system. So we've got the GS18i on top of here. That's giving a centimetre accurate position of where this unit is being pushed. Right. Which is absolutely key. So mapping of these utilities, bringing these sensors together, these sensors working together to give us, we've got accurate GPR data. We now know where that GPR data is. If we've got correct positional data to the site grid or whatever we're working to, that can then be uploaded to machines to allow us to avoid them going forward.
So folks, what's really interesting about this is it's all about safely, but actually productively doing the job site work, because we do this first and right. We know we haven't got to do a lot of the other works that people would maybe do as a remedial sense.
Absolutely. So the correct specified utility survey at the outset of a project, whether that's something like PAS 128, that information then can be used, as I say, by the design teams. And then once we get to site, we can revisit, we can repeat this work if necessary, or the guys using cats and jennies and those sorts of things can add that information in as well. So we're constantly thinking that there's something underneath the ground. We're aware of these things, and it's not out of sight, out of mind. We're constantly thinking, hang on a sec, let's not have an incident, let's not strike a cable, this keeps happening. So we need to look at changing workflows and changing how we work to make our sites safer for us all.
And the great thing about this, folks, is when we've finished and we've put them down, we can go over again and get the absolute accurate level with this technology to say it's definitely there. We've got a 3D underground model, a massive big building above us or whatever it is, structure, and therefore that is there for the rest of the life of that particular part of the UK ground.
Absolutely, yeah. Keeping that information is key. Putting the data from here to work for the future and keeping that for the benefit of the site going forward.
Fantastic. Thanks very much for explaining
the
tech that goes underground so that when we're digging down, we don't make the mistakes that could be horribly shocking in a number of different ways. Electricity, gas, and water, all of those sort of utilities, and of course, the lifelines of what I need for my job, the internet, is actually, going to stop if we use these properly and if we get the models right, and also if we get the avoidance into the cab that's also got the 3D machine control. Whew, there's a lot to take in there, Shane, but do it all right. Dig once, dig well, off-site, off we go. Cheers.
Brilliant. Thanks, Peter.